All right, so here's number 7 from our homework. Again, we're going to be going through, finding all of this information, and we're going to be doing a graph. Let me put our axis over here. The first thing, again, that we want to do is start off by finding our translation. So the first thing we can do is we look at this. X plus 1 right there, that's telling us to go left 1. And this 2 that's sitting out in front, it's a positive 2, so it's telling us to go up 2. Now that negative doesn't apply to it. The negative is just going to make it a negative graph. So we're going to go left 1, up 2. Again, we're translating from 1, 0. So 1, 0 is this point right here. Again, we're going left 1, up 2. And that puts us right there on the y-axis, right? That's our starting point. Again, since that is our starting point, that means that our asymptote is going to be one step to the left. So we just go left 1. This right here is our vertical asymptote. It's x equals because it's up and down, and it's at negative 1. So our vertical asymptote is x equals negative 1. The other nice thing about that point that we found is notice how it's on the y-axis. Since it's on the y-axis right there, what that means is that's actually our y-intercept. That's where it crosses the y-axis. It intercepts the x-axis, or the y-axis there, sorry. That's at 2, so our y-intercept is 0. We went up 2, so it's a positive 2. Now, hold on, let me grab my eraser real quick. Now, what we need to do is find the x-intercept. That's going to make our lives a lot easier. Now, again, to find the x-intercept, we're going to replace y with 0. So we have our starting equation. Let me rewrite it here. 2 minus log base 2 of x plus 1. Wherever we see y or f of x, that's the same. We're going to replace it with 0. So we're going to have 0 equals 2 minus log base 2 of x plus 1. And we're going to solve this for x. The first thing we want to do is isolate this log base 2 of x plus 1. What I would do is we can just subtract 2 here, right? Move it over. We do the opposite function. That's our inverse. We have negative log base 2 of x plus 1. And then to get the log completely by itself, let's get rid of this negative here. To get rid of it, we just divide both sides by negative 1. So we have 2 equals log base 2 of x plus 1. Now we have isolated that log, right? We can set up, we can go from this log form into that exponential form to solve this for x now. So it's 2 to the power of 2. So 2 to the power of 2 equals what's inside of our log is x plus 1. We just need to solve that now. 2 squared is 4. Solve it for x. Hopefully you got that. 4 minus 1 is 3. We get that our x-intercept is at 3. So we're going to go over here. You're counting from 0, 0. So write 1, 2, 3. That's where your x-intercept is. That's at 3, 0. Again, from that, that's what we can do our sketch of. Notice how it's kind of upside down. That's because it was a negative graph, so we know it should be decreasing. And we just need to answer our domain and range. Again, domain is left to right. So let's just start there. The farthest to the left this reaches is negative 1. It's in parentheses. It hits an asymptote, goes to the right forever. Range is how far down to how far up does it go. Again, this graph is going to go down slowly forever. So our starting point for our range is negative infinity. The highest point it reaches, that's going to keep shooting up forever, so to positive infinity. Again, that's how you're going to go through and do number 7 there from your homework. If you have questions,